Today we're going to talk about a special number, which you're going to find out is the natural number, which naturally turns into the natural base and a natural log. Let's use the back of that folded colored notes paper. Let's use the back of it, and we're going to fill up these last 4 spots. Talk about the natural number. Use that first box in the upper left corner. Let's find out a little bit about this natural number. First off, I guess I better tell you what it is. Okay, it's actually so special that it gets a letter. It gets called by the letter E. Okay, now the letter E in math is actually equal to the number 2.7, and then depending on how many decimal places you want, 2.718. I know it doesn't look really that special, does it? It's just 2.718, but you see, this number actually comes from, well, nature. That's why we call it the natural number, because when you investigate nature, you find out that things in nature change in a continuous fashion. So when something changes in a continuous fashion, we call natural or continuous change. Now, we don't really have the time to really get into, okay, so what does that have to do with the number 2.718? But for the sake of what we're doing in Algebra 2, that's what you need to know. When that number E, which is equal to about 2.718, when it becomes the base of an exponential equation, then it looks like e to the x. And e to the x will be an exponential growth graph. But officially, we would call it natural growth or continuous growth. Well, it just really looks like any other growth graph that we would draw, but it does have a special base. It's got the base E. Now that base, it turns out that can become the base of a logarithm. And when it is the base of a logarithm, we have what's called the natural log. Now the natural log gets a new spelling. It kind of gets a unique abbreviation, ln. That's an ln. What is ln? Well, it's literally a log with a base e, except you're never going to see us write loge, because when it's a base e, it gets a new spelling. It's called the natural log. So what is an ln? Well, it's a log with a base e, except you're never going to see it written with a base e, because when it's a base e, it gets a new name. It gets a new abbreviation. Literally, we just call it the ln of x. Now here's the thing, ln is still a log, and so everything that logs do, an ln does, which you're going to find out in this short lesson is what we've already been talking about. E and ln are inverses. That's going to be basically the main idea that you're going to need to know moving forward, that E and ln are inverses. And what we can do is we can use that idea to help us solve equations. So what we're going to do now is we're going to move into solving an exponential equation. Let's move to the next box. We're going to solve the exponential equation 2 e to the x plus 1 equals 60. Now, clearly this is an exponential equation. It's got x up in the exponent, but notice also that it's got this special base. It's a base e. What are we going to do? Well, we're going to do what we always do. We're going to isolate the main part of the equation. So dividing by 2 is definitely step 1. And when you divide by 2, you end up getting e to the x, of course, equaling 30. But now we're ready for the key step. The key step is to slap both sides with a log. Now, this time, when I slap both sides with a log, I'm going to use a natural log. Why am I using a natural log? Because it cancels with e. You see, they completely cancel. You're not left with anything except the x plus 1 that came tumbling down. Now, on the other side of the equation, we get the ln of 30. The ln of 30 is something you're going to have to type into your calculator using the ln button. So go ahead and see if you can find the ln button on your calculator. You should see on most of the calculators that you guys use that it's right underneath the log button, but it's a special button. It's the ln. And when you use that button, you can type the ln of 30, and we get about 3.4. So again, we got the ln button. Make sure you can do this on your calculator. Okay, so if you didn't get your calculator out yet, you need to get it out now. Once we get 3.4 to a few more decimal places, then of course you can subtract 1 and you end up with 2.4. If you have an e, then you use an ln. Literally, you slap both sides. You slap both sides with a natural log. Okay, because e and ln are inverses. All right, now we're going to slide down to the next box, and we're going to talk about a logarithmic equation. But this time the logarithmic equation is going to have an ln. Don't panic though. It's not a lot different than what you normally would do, because now we need to get rid of the ln. We need to base both sides. Now remember, an ln assumes to have a base e, but you're never going to see that little e written there. But we're still going to use a base e. We're going to base both sides with an e to cancel that ln. And you get x minus 3 equals literally e to the 4th power. E to the 4th power. Sounds like something you're going to want to do on your calculator. Okay? Get that calculator handy again. You want to find the e button. Now the e button, or the e to the x button, is probably the one that is associated with your ln button. For most calculators, it's going to be a shift or second ln. So make sure you try it. Find your e to the x button, and you end up, when you do e to the 4, you end up with 54. So we based both sides with an e, and you literally get e to the 4th power, again, which is about 54. And then you can add 3, so end up with 57 with a little change. If you have an ln, you're going to use an e. You're going to base both sides with an e. Now, usually students will catch on quickly here that essentially what's happening is if you have a e, you're going to use an ln, and if you have an ln, you're going to use an e. They always go together because they are inverses of each other. But I'd like to talk to you about one more equation. It's a little more of a doozy, okay, because this equation is going to require us to do some condensing. Now, condensing is a special math word that we use when we have more than one log. Here, we have 2 logs. Now, they're natural logs, but there's 2 of them, and so we're going to have to pull them together. Now, before we do that, I just want to make mention, this is not the number 21, nor is it the number 31. I know it kind of can look like it, but you have to understand that it's an ln, it's a logarithm. So I know it's written in a lowercase l. That's normally how it's written. I mean, you can make it uppercase if you want to, but the main thing here is to understand that the number 2 actually needs to come up as an exponent, and so does the number 3. Remember, before you do condensing, you have to move coefficients up as exponents. Now, once I get that first step taken care of, I can get ready to actually condense, and when there's a plus sign, remember that you condense by multiplying. So you're basically going to multiply your x squared and your 3 to the third. Of course, 3 to the third is really 27, and I'll multiply that by x squared. It's been condensed. It's a single ln. And now we can base it. We can base it with an e. So we're going to end up with e to the 7th. Now, e to the 7th is a bit of a larger number, right? So make sure you can do it on your calculator. It's a number in the thousands. After you divide both sides by 27, you're going to end up with 40. And when you take the square root of both sides, you're going to finally end up with x, which is equal to about 6.37. Okay, so we had to condense the problem by first moving those coefficients up as exponents, and then we could pull it all together using multiplication. Just kind of a real quick, don't do this. Don't get too excited and use e too soon. You're not allowed to use multiple e's on one side of the equation. That's why you have to condense it to get one log so that you can use e just one time on each side of the equation. All right, that's your special base e, and that's your special log, the natural log. Now you're ready to take a look at the riddle sheet. The riddle sheet that was passed out with this lesson.